All right, now we're going to talk about zero force members in a truss. And what do I mean by zero force members? Well, it sounds exactly like what it means, right? It means I have a member that has no load in it. Members that carry no load in the current configuration of the truss. So if it's not carrying any load, why is it there? Well, maybe it's necessary for stability during construction. And maybe it's not going to be a zero force member if the loading changes. So they're members that don't have any force in them. There's no load, but they're there for a reason, or at least were there for a reason, and maybe there for a future reason. There's two different cases of zero force members that we can look at. Case one is if there are two non-collinear members that meet and there's no external load or support, then the force in both members is zero. So if there are two non-collinear, non-collinear, that means they don't fall in the same line. Members meet at a joint and there's no external load or a support present, then both members must be zero force members. That's why zero force members can change, because if there is a load, then this case doesn't apply. If the loading changes, so there is a load at the location. So if they meet, they're not in a line together, and there's no force there, and there is no support, then there is zero force within that member. There are two pairs of zero force members that meet the case 1 criteria because there's two. One is if we go look at joint C, right? I have a vertical force, a vertical member, and a horizontal member, and there's no external load or support. So that means that the force in BC is 0 and the force in CD is 0. How can I prove that? Well, let's say I do the sum of the forces joint C. Sum of the forces in the x direction is 0. If I look at joint C, it has the joint, and it has force BC and force CD. If I do sum of the forces in the x direction, the only force at C is my force BC. Similarly, if I do sum of the forces in the y direction is 0, the only force I have is force CD. So they're both 0 force members. They meet the criteria for case 1. Let's look at joint A. Let's look at joint A. Right, I have a horizontal member FAE, the force from FAE, right? Let's see, here's A. I have the force from that horizontal member. I have a diagonal member AB, and the force from that. Let's say I do the sum of the forces in the y direction is 0. The only y direction force I have is the horizontal, is the vertical component of the force in member AB. So that means the force in member AB is 0. If I look at the sum of the forces in the x direction equal to 0, well, I should have my ABX component, and my force in my member AE is equal to 0, but I just said this was 0. So that means that the force in AE has to also be 0. Right? If you look at joint A, There is no other vertical component unless I add a vertical load or a support that provides a reaction in the vertical direction. So member AB is a zero force member and member AE is a zero force member. There's also a fifth zero force member, and we'll come back to it in a minute. Okay, so that's case 1. Case 2 is if 3 members meet and 2 of them are collinear, then the one that's not collinear has zero force in it. Sounds like a beginning of a joke, right? If 3 members meet at a joint, and 2 of them, right? If 3 members meet at a joint and 2 of them are collinear, then the third one feels a little bit left out. Again, with no external loads or support at that joint. Then the third guy is like, a bit of a third wheel here, right? And has zero force in its member. So 3 members meet. 2 of them are collinear. They share the same line of action. Their vectors are parallel. Then the third one doesn't have any force in it. There are actually 2 instances of this. One leads to the other. So the most obvious one, well, if you go look at D, I have 2 members that are collinear, CD and DE. Then this third guy, kind of third wheeling it. So that means F, the force in member DF is 0. Now how can I prove that mathematically? Let's look at joint D. It has these 2 members coming into it that are in the same line, and then the third guy that's actually perpendicular. So F, DE, F, CD, and then F, DF. And one kind of way to look at this, especially because this is perpendicular, right? You can see if there's actually a different coordinate system that's parallel to these members, that's in line with these members, right? X prime is parallel to member FD. Y prime is parallel to members CD and DE. And I can still take the sum of the forces about those two axes. I can just rotate my coordinate system, right? Take the sum of the forces in the X prime direction. I guess kind of like F this way is positive. Is 0. The only force in that direction is the force in member DF. So that's why it is a 0 force member. There is a second 0 force member. Basically, because FDF is 0 force, I have the same thing going on at joint F. If I look at joint F, I have 2 horizontal members, EF. Oops. Let's draw the force there. Force in member EF. I have the force in member FG. I have the force in member DF, but I just determined that was 0. And then I have member CF. So if I take the sum of the forces in the Y direction, the only one that has a vertical component, because FDF is 0, is the vertical component of the force in member CF. So that's how I get my second 0 force member. Now, if I go look there is a very similar joint B is similar to joint D, but the reason it doesn't qualify is because it has an external load on it. You see that load P has, I can break it down into components. And you see one of those components is in the same direction as member BG. So member BG will have some load in it. If load P was up at C, then member BG would be a 0 force member. Of course, then member FCF would still be 0 too. Yeah. And FCG would then be 0. And then really what's holding things up, right? So that's why B doesn't work, because it has that external load in it. If I go back to this case 1, has everybody found the 5th 0 member force? It kind of looks like case 2, although it technically has a support. But the reason that it qualifies is we look over at joint E. It only has a vertical reaction. So if I do sum of the forces in the X direction at E, I would have the force in member AE, which is 0, and the force in member ED, which now has to be 0. Or DE, whatever you want to call that. If E was a pin, that would not be true. But because it's a roller and only has a vertical reaction, there cannot be force in member DE. So if you look at it, the only two members with forces are BE and BD. The other two must have been there for fabrication, or maybe if my load changes. But right now they're just kind of taking up space. Maybe they're providing stability. So anyway, so that is the two cases of zero force members. So let's do an example. Not going to do any equations here. We're going to just kind of eyeball it. There are 5 zero force members. Take a minute and see if you can find all 5 of them. Well, I have a case 1 at joint D. I have 2 members that aren't collinear, but there's no external load. So FCD is 0 and FDE is 0. I have case 2 over at joint H. AH and FH are in line. So the oddball out is FBH. So it's a zero force member because these two are in line, that guy gets left out. My other ones are FEF. My force in member EF is 0. If I take the sum of the forces in the x direction at E, there's not another horizontal member force because DE is 0, so EF has to be 0. And finally, if I look at my reactions here, I only have a horizontal reaction. Oh, geez. At X, or at G, I only have a horizontal reaction, but I have a horizontal and vertical reaction at A. So if I look at G, if I do the sum of the forces in the Y direction, member AG can't have any force in it. I don't know if that's a good word to write, but yeah. F member AG. Okay. So identifying the zero force members means you can automatically count out things that you don't have to calculate, right? If you can look at it ahead of time and say, oh, that's 0, that's 0, that's 0, that's 0. Now I only have 1, 2, 3, 4, 5, 6, 7 unknowns. Unknown member forces plus my reactions. I got rid of 12. Or get rid of 5. 7 plus 5 is 12. Okay, so that is a summary on zero force members within a truss.